Foundation. So today's topic, I think, is 1 trillion AI agent or something, right? So yeah, thank you for joining. And remember the Wi-Fi password is AI. Yeah. So you can make sure you connect the Wi-Fi first. And yeah, I think we can right now start the workshop. Thank you.
Use this one? Okay. Thank you, Jennifer. Turn that one off, maybe. It's also on. Right. Hey, everybody. Very excited to be here. Thank you to XueDAO. Thank you to Taipei Blockchain Week for hosting me, for hosting us. I'd like to share the very first presentation I ever gave in the blockchain industry was actually here in Taipei in 2017. I'll share a bit more about my background in a moment. I've missed this event the past 2 years. I finally made it this year. I'm very excited to be here, support the local community in Taiwan. Did not want to miss that opportunity. I'm Lane. I'm head of research for the NEAR Foundation. I'll just use my bad Chinese and very briefly introduce myself. 大家好，我中文名字叫欧脸。这个欧脸有点像区块链，欧是妻子。然后我其实今年我刚刚搬来台湾，所以我现在就在这边。我非常怎么说？非常开心，今天有一个机会亲自来支持你们这个当地这个台北的区块链的社区，特别是你们学到的。So if you want to keep in touch, if you want to reach out to me, my contact information is here. I'll share in just a second. So 中文、英文两个都可以，无所谓。So feel free to keep in touch in Chinese as well. I'll do my presentation in English because, sorry, I don't have all the vocabulary necessarily in Chinese. So very briefly, I'm going to introduce myself. I'll introduce, sorry, I want to make sure the video and everything is okay too. I'll introduce NEAR Protocol, NEAR Foundation. I'll talk a little bit about some of the technologies that we're working on at NEAR. And then I'm going to spend most of the time today talking about a particular technology that we've developed called shade agents, right? So this is a way to run persistent, verifiable AI agents on chain. Obviously this is a workshop. I know many of you have your laptops with you, so we'll actually roll up our sleeves and do a little bit of building together. And then, I'll save some time at the end if people have questions as well. If you want to follow along, so I understand that my screen is being shared, so you can follow in the Google Meet, or if you want to just use this QR code, this goes directly to the slide deck. So you can also, there's some links you might want to click on. I tried to include QR codes in a number of places, so if you want to go to the GitHub repository, if you want to download the tools, etc., there will be QR codes later, but you can use this QR code as well to just view the slide deck and just see everything that I'm presenting here. I'll leave that just for a second. Okay, so again, I'm Lane. I'm head of research at the NEAR Foundation. NEAR, I'll introduce NEAR more thoroughly in a moment, but NEAR is a layer 1 smart contract blockchain ecosystem that's very focused on AI. I'm older than I look. We had this conversation yesterday. I've been working in IT industry for about 30 years already. I've been working full-time in blockchain since 2017. So my first full-time role was with the Ethereum Foundation. 2017 to 2019, I was an Ethereum core developer. Then I spent about 5 years, almost 6 years, building a blockchain called Space Mesh that some of you might have heard of. Actually, we sponsored ETH Taipei last year, and I ran a workshop for Space Mesh last year, so it might be familiar. And then, I joined NEAR pretty recently, at the end of last year, although I've been kind of a fan of the NEAR project and a member of the community for a very long time. This is my contact information. Feel free to reach out to me, email, Telegram, Twitter. My DMs are open on Telegram and X as well. And I'll put this up again at the end if you want to get in touch. But I'm easy to find. All right, so let's start with an introduction to NEAR. Right, so NEAR actually started as an AI project. Maybe I can even just jump ahead. All right, never mind, it's too far ahead. NEAR actually started as an AI project in 2017. I'll talk a little bit about the backstory in a moment. And then pivoted to blockchain because there were certain problems that our founders were trying to solve that they needed a scalable blockchain to solve. So Near is a smart contract platform where everything is designed for ease of use for AI applications, for building AI applications on chain. We have a number of different focus areas, a number of different pillars, which we'll talk about: usability, scalability, developer experience. And really, basically, our core mission is to just make Web3 development accessible, easier, and allow people to really take ownership of their data and applications. So in a snapshot, right, we have very fast block time, very fast finality, right up there with Solana and other projects like that. So under a second block time finality, which actually has been sped up recently. Another cool thing about Near is that we have named accounts, right? So we've had account abstraction since the very beginning. So my Near account is lane.near. It's actually free to claim a named account on Near, so I encourage you guys to do that. So you can, it's about better developer experience and better user experience. You don't need to use the really long, complicated account addresses that you do in like Bitcoin or Ethereum or Solana or other accounts. Every account is a named account by default. We'll talk about things like chain abstraction, intents, AI, etc. So what are the core components, right? In addition to the blockchain, in addition to the protocol. So the four pillars are sharded infrastructure, chain abstraction, near intents, near AI. I'm going to discuss each of these one by one. And then we'll double click on the AI stuff, because this is obviously an AI event. So speaking as a blockchain core developer, as someone who spent many years working on Ethereum, working on Space Mesh, and now on Near as well, scalability is really, really important and really difficult in blockchains. Going back to when I worked on Ethereum 2017, 2018, 2019, the design for Ethereum was actually to be a sharded blockchain, right? To have many, many different shards so that you can have any number of accounts, run any number of applications, and effectively have an unbounded number of transactions and transaction throughput on Ethereum. Of course, Ethereum went a different direction, right? The Ethereum roadmap changed with a focus on rollups, layer 2s, things like this. But Near actually really embraced the sharded design. And sharding is a very tried and true and tested scalability model, right? That's very common in the Web 2 world. It's very common in databases. And it really allows you to achieve, again, effectively unlimited scaling. So we, just this year, have already scaled Near from 4 to 6 to 8 to now 9 shards. And each shard is like its own blockchain. So every time you add a shard, let's say every time you double the number of shards, you double the transaction throughput, right? But again, because developer experience and user experience are a core focus, the shards are transparent to the user. The user doesn't need to worry which shard their account is on, which shard their application's on. Any account on any app and any shard can interact with any application on any shard. And the way this works is the transactions in Near are actually asynchronous, as opposed to other blockchains where they're synchronous. Again, that's a bit of a technical detail. I won't go into detail on that today, but this is a core piece of the design. We plan to scale Near to 1 million transactions per second, and we're well on our way to doing that. There's no technical obstacles or roadblocks. We'll probably do that quite soon. And we feel that a blockchain for the future, a blockchain for an AI-enabled future, needs to have extraordinarily high scalability and very fast block times, because AI agents will be producing many more transactions than humans. The second pillar is chain abstraction. So Near has always embraced a kind of chain agnostic vision of the future, and this is one of the reasons I'm very excited about Near myself. We kind of have this term we use, post-maximalism. So many people in so many blockchain communities today are really maximalists, like, oh, one chain to rule them all. It's going to be Ethereum, it's going to be Solana, this and that. Near has really leaned into the opposite approach, which is that we have this technology called chain abstraction that allows you to use a single set of keys, a single Near account, to run applications across every different blockchain. And we'll talk a little bit more about how that works. There's some fancy technology like an MPC solution under the hood. So you can build chain agnostic applications on Near. And we think about Near, as it says here, as kind of the single user-friendly entry point into this multi-chain ecosystem, this multi-chain economy. The third is Near intents. So intents are a very different way of constructing blockchain transactions. They offer a very superior user experience. So the way that blockchain transactions work, if you're familiar with Bitcoin or Ethereum or Solana, most blockchains today, it's kind of declarative, right? So your wallet constructs a transaction that says, I'm going to call this particular function and this particular smart contract with this particular input. Intents is a very, very different approach, a different way to think about transactions on a blockchain. It's a much more natural human way, right? So the best example is a swap. Let's say I have 1 ETH and I want to swap it for NEAR, something like that. Again, in the traditional world, you would you go to a DEX, you go to Uniswap, something like that. You would find a particular method on a particular contract and kind of not necessarily know what the outcome of that transaction is going to be. With intents, you're saying something very clear, right? You're saying, I want to swap this amount of this coin for this coin, and I want to not pay more than a certain price. It's really, again, a very natural way of transacting. And then the way intents work is that we introduce another category of kind of actor, right, called a solver. And so solvers listen for these intents on the network, and they figure out how to solve the intent, right? So they figure out how to fill your trade request, something like that, to get something done for you. We're not the ones who invented this idea. There's a project called Anoma that's been working on this for a few years. There's a number of other blockchains working on intents. But NEAR Intents is a really successful project, actually. We've seen an enormous transaction volume flowing through this. It's found product market fit. I think it's quite exciting. And again, it just leads to better applications, better user experience, better developer experience. And then finally, NEAR AI, which again, we're going to focus on more today. As I mentioned a moment ago, NEAR began as an AI project in 2017. And so, we have a lot of infrastructure, a lot of components, including a NEAR AI cloud, that just make it really natural and really easy to build AI native applications and to integrate them into smart contracts. And in fact, that's exactly what we're going to do in the workshop component today. We have this open agent ecosystem that we're a part of. We have AI-powered wallets. We have a number of different kind of autonomous agents and things you can use in the NEAR ecosystem. Integrations into different LLMs. This is actually our main focus going forward. We're going to be focusing on kind of verifiable, secure AI infrastructure in addition to the blockchain stuff. Okay, so I keep talking about the past of NEAR, so let's kind of look a little bit at where we're coming from, where we're going. This is a glance at the technical roadmap of NEAR. Trying to think about how, it's going to take a long time if I talk about each of these in detail, so maybe just very, very high level. Chain signatures I mentioned a moment ago, right? That's the core primitive that enables the multi-chain applications. So there's various improvements here in terms of the cryptography and the hardware support for that. Omni token, this is an idea that you can, if you want to create a new token, today you have to choose a blockchain. Right, you say, I'm going to launch on Base, I'm going to launch on Solana, I'm going to launch on Avalanche, Arbitrum, whatever. An Omni token is a token that natively, naturally exists across every blockchain using this NEAR chain signatures technology, which I think is quite exciting. So you don't have to choose anymore. Reducing the block time, speeding up finality even further, just to 1 second. Sharded smart contracts, we talked about that. Reading data from other chains, right? So your smart contract, your application on NEAR can natively interact with applications on other blockchains using chain signatures. I think that's quite exciting. I've said this a few times now, that NEAR was founded as an AI project in 2017. So these are our co-founders, Ilya and Alex. They're both AI pioneers, early employees working on AI at Google and at OpenAI back in the day. They were working on a project. They founded NEAR as a startup to effectively use AI to teach computers how to write code. And they were a few years too early. And also, again, they found that they needed blockchain technology in order to make all this technology kind of work. And so they pivoted into building the blockchain technology back in 2018. And I should mention and give a shout out to Ilya, our founder, my boss. He's really well known in the AI space as the co-author of the Attention is All You Need paper. So the T in GPT, right, is the transformers. So this paper, this project, and his research actually kicked off the entire modern AI revolution back in 2017. Again, there's a lot of projects that are working at the intersection of crypto and AI, but I think it's very rare to have leadership like Ilya, right? Someone who really has been a world-leading pioneer in this industry as long as he has, right? For more than 10 years. I won't spend too much time on this. This is, and again, this, the slides are public. I'll share the link again. You can spend more time on this later if you're interested, but this kind of just is a high-level overview of Near's AI offerings relative to some of the other projects you may be familiar with in both Web3 as well as Web2. I think Near is very unique in the sense that we are not just an AI-specific blockchain. We're a general-purpose smart contract blockchain, unlike BitTensor, for example. We're highly decentralized. We're building out community governance, right? Whereas I think a lot of, obviously if you look at OpenAI or Anthropic, they're obviously centralized companies, right? So there's a very different kind of trust model there than there would be using the decentralized AI infrastructure from a provider like Near. And I think in a nutshell, our value add and our unique value proposition is actually delivering very similar infrastructure to what you get from an OpenAI or an Anthropic, but doing it again in a decentralized kind of community-first fashion, where you own your data. All right, so that's it for the introduction. Now let's talk about the main topic today, which is this technology called shade agents, right? What is a shade agent? Why does it matter? If you want to run an AI agent in the Web3 space today, you have two choices, right? You can run it in such a way that it's trustless and verifiable, and that means it's running inside a TEE, a trusted execution environment. The problem with that is that it's centralized, right? There's no way to do that in a decentralized way. And so if the TEE provider goes offline or disappears, you're done. Your application is dead, the memory is lost, et cetera, right? Or you can run the agent in a way where it's persistent, and this is what most of the kind of AI crypto projects are doing, but then they're centralized, right? And you don't have any kind of guarantees about correctness, right? So just to reiterate, right, TEE-based agents, you have trustlessness, but you don't have reliability. Keys can get lost, funds can get lost, et cetera, so single point of failure. You can have centralized agents that solve that problem, but then what's happening inside is opaque. You have no guarantees. You can't really trust what's going on because they're running on someone else's computer, basically. And they might steal your keys, for example. I want to just briefly share that this isn't just a theoretical problem. This is actually a problem I've personally encountered a few times. So I have friends who've built things like a trading bot, like a trading agent, right? And I'll give you an example in a moment of a trading agent that we built. And they say, look, my trading agent is amazing, it's making a lot of money. All you have to do is give it your private key, right? And then it will, it'll go off in the market, it'll trade for you, it'll make a lot of money. The problem is I don't trust it, right? I don't trust it with my private key, even just a little bit of money, because I have no guarantees that it's not going to misbehave or leak those keys to someone else. The solutions we're working on here solve that problem. Another good example is like a Telegram bot. So there's a number of companies that have developed an AI agent that joins that you give access to your Telegram account, and it does amazing things. It can organize your folders, it can find people you ghosted, it can give you a daily summary. But again, the problem is you have to give it effectively complete control, like root access to your Telegram account, your Google account, whatever it is, your Slack. And maybe it's just me, but I don't trust someone else's code when I don't have verifiability guarantees. So I think these verifiability guarantees that we get with things like TEEs are really, really critical and really valuable and important. So these shade agents are AI powered, right? They can do things using LLMs. I'll explain how they're natively multi-chain because of the technology we talked about before. So they can hold any asset on any chain. They're not custodial because no one controls the keys. They're kind of, the signing happens using MPC, so it's multi-party compute. It's a set of trusted validators. There's no individual validator who holds the keys. Everything is verifiable. So the code is known, the code cannot be tampered with. It's confidential. All the inputs and outputs are completely confidential and encrypted. They're flexible. They can interact not just with on-chain data, but off-chain data as well. And actually, they're very cheap to run. The overhead of doing things in a TEE is actually only like 10 or 20%. We've done some research on this. So it runs at almost completely native speed, which is really exciting. So how does it work? You have what's called a worker running inside this trusted execution environment on a GPU. And it has a private key, and it has access to an LLM, which is kind of the brain. And it can, again, talk to the outside world using APIs and accessing storage, right? This is kind of the single building block, the worker agent. Then the question is, okay, well, how does it do anything on chain, right? And the way it does that is that there's an agent contract that it talks to, okay? And the agent contract, it calls to the agent contract and it gives it a code hash and an attestation. So the code hash is the hash of everything running inside the worker. And an attestation is a signature using the private key. And on that basis, the agent contract is able to verify that the TE is genuine and that it's running the correct code. And so you can think about this a little bit like arriving at a bar or nightclub and like showing your ID at the door to prove that you're old enough or that you have a ticket for the event or something, right? That's kind of what the agent contract is doing here. And then when a transaction is needed, the transaction is generated by the agent contract. So it creates the payload of the transaction and, the worker creates the payload of the transaction, passes it to the agent contract, and asks the agent contract to sign the transaction. And then that's how it's submitting a request on chain to get something else done. When the contract receives a valid request, again, it has to authenticate that request. It signs it using the MPC technology. So again, the collective key signing ceremony.
Could you say that again?
And again, it can submit that transaction to any blockchain. So you can interact with Ethereum, Bitcoin, Solana, et cetera, et cetera. We actually have support for, we've been adding a new chain almost every week. So we have support for something like 24 chains already. So this is kind of the life cycle of a single task. But it's important to point out that there's actually many workers, not just one. So this architecture is designed to support many, many independent workers. In the way we just described, there's no single point of failure, right? And this goes back to the first point I made. If you want robustness, if you want to make sure that again, there's no single point of failure. If a particular host goes offline, if a particular data center goes offline or something, you have redundancy. You have many, many, many workers, right, who can step up and perform the same task for you. So that's basically the idea of a shade agent, right? You have both of these parts. You have the worker agent that runs off-chain in a TEE, and you have the agent smart contract that's on-chain. And the workers get verified on-chain and can access the signed transaction function, which allows them to do things on-chain across different chains and different accounts. And any agent that runs the correct code inside a TEE can verify and access the same accounts. So again, you have redundancy built in as well. So there's no single point of failure. Yeah, this QR code will take you to more documentation on shade agents. But we talk about smart contracts a lot. Smart contracts are a great technology, but they're very limited in what they can do. In particular, they can't talk to, they can't do inference. They can't talk to LLMs on chain. It was never possible for smart contracts to serve as these agentic protocols. This is, to my awareness, kind of the first time that you can do that using this technology. And again, it was never possible for fully on-chain Web3 agents to serve multiple users without the trust factor, and we've removed the trust factor here. And yeah, I think the best way to think about this is like, if you want to do an AI task that's not a one-off, right? You want to have something persistent. You want to have an agent that's just running in the background, trading on your behalf, organizing your data, sending emails for you, doing things on chain for you. You need a technology like this to do it. And here's some examples of things that people have built using this technology. A yield optimizer, and what that does is it takes your coins that are in an Aave or compound or something like that, and it constantly finds the best rate. So let's say you have USDC and you want to earn yield, and you deposit it into Aave on, Arbitrum, and you're earning 3%, and then tomorrow Optimism is offering 6%, which is how this actually works. So the yield optimizer is an AI agent that, again, you can trust it, right? It's not, you have guarantees that it can't steal your coins, basically, and it just moves them around on your behalf. So it migrates them from Arbitrum to Optimism to chase the higher yield for you, right? It's a very, very powerful idea. You can run private DAOs, staking protocols, crypto treasuries. There's a few projects that are doing exciting things here. If you have an AI strategy for treasury management, social prediction markets, these are actually things that people are building today using this technology in Near. And these are things that we would like to see people build, so we'd be excited to talk to you if you're interested in building any of these things. Agentic protocols, decentralized exchanges, oracles, that's a natural thing, and actually the example we're going to do today is an oracle example. Telegram authentication, I talked about this as a problem You want to have a trustless Telegram bot. You don't need to trust that it's not going to, hijack your account or something. Just tooling like Dockerization to run LLMs. I'll go through this very, very quickly, but this is a concrete use case, a case study of a project that was built. I mentioned a moment ago, autonomous trading bots. So we actually built this internally as a proof of concept. It uses Kaito for folks who are familiar, right? Kaito is a social protocol that lets you track kind of sentiment on social channels like X. We basically built a trading bot to trade certain coins using sentiment analysis. And it earned a lot of money. It earned 41% return in just a month and outperformed both Bitcoin and Ethereum. And sorry, this says not financial advice, do your own research. I believe the code is open source, but you're welcome to play with it. So it was launched with 10,000 USDC, and it ended the month with 14,156 USDC, right? So 41% return. Very, very interesting if you actually look at the pattern of behavior here. So in the early days, it was doing a lot of very small trades, just kind of testing the market, trying to understand what was going on. Exploration mode, right? Diversified trades, diversified positions, minimizing volatility, things like that. And then all of a sudden it began gaining conviction and moving into much larger bets. So you can see on the 9th day here, it decided to buy $2,000 of Bitcoin and made $500 on the following day. And then the back half of the month, very, very interesting, it began making very bold trades and earned, I don't know, $1,500 in one day here, which I think is pretty awesome. And it wasn't random, to be very clear, right? It was really responding to real-time price signals online. So this is, again, it's just we're not traders, we're not market makers. This is just a proof of concept, but it shows the kind of things that are possible with this technology. So you have to have an appetite for risk here, but technologies like this can be profitable, time the market, and just act decisively when we're asleep, effectively, which is why AI agents are exciting. We have an article here in the blog that explains this experiment, and I think the code is there as well, so if you're interested, take a look. So kind of in conclusion on shade agents, autonomous agents, there's a Telegram group here in the middle. You can just look for shade agents on Telegram. You can join the group. I'm also there as well. If you have questions, if you want to build, you can. We offer support there. You can read more about this experiment, and I want to make sure we save a little bit of time for the workshop. I think we have about 20 minutes left. So let's actually roll up our sleeves and try deploying a shade agent together in the workshop portion. I think this is the same QR code I used in the beginning, but if you scan this, it will take you to the deck. There's some links and things in there that we can use. Live demos are always risky, and I know that Wi-Fi here is not super strong, so we're going to try to do this together. Apologies in advance if it doesn't completely work. But here's what we're going to do. We're going to create a testnet account on Near. Should be pretty easy to do. We're going to clone a template for the shade agents, which is down here. And again, if you scan this QR code, it will take you to the documentation. You can follow along, or you can just go to github.com/neardefi/shade-agent-template. And we are going to actually run the shade agent in a TE, in a trusted execution environment, using our partner called Fala. If folks are not familiar with Fala, it's a decentralized network of GPUs that provide secure GPU compute using TEs. Pretty exciting technology. All right, so let's try to do this together. I'm going to adjust my screen sharing here. Try not to screw that up. First step is you need if we're going to create a testnet account, you need a 12, 15, 24-word mnemonic. I recommend using this tool, this website, to do it. So let me go ahead and try to share my screen. We can do it together. Right. All right, sorry, I know there's a lot of different windows and things going on here. Hopefully this is still working. So let's start by generating a mnemonic. If you clicked on that QR code here, you can also just type in this URL, iancoleman.io/bip39. I'm going to click on generate. Okay, now I have a random mnemonic here. I promise there's no crypto coins in this mnemonic. All right, and then let me open up the Shade Agents documentation so we can go through it together. Like I said, sorry, the Wi-Fi is a little bit slow. Bear with me. Okay, yeah, so the documentation is also here in GitHub. Let me make this a little bit larger. All right, so first thing is to clone this template. Yeah, so for anyone who's following along, I'm just, so far I'm only using Git, right? I'm just going to clone this particular URL, this particular repository, the Shade Agent template. And I'm going to Shade Agent sandbox template. I think this is correct. Let's try this. Good. If anyone gets stuck or has questions, just raise your hand. We can go through it together. Okay, the next step is installing the Near tooling, right? This is the tool that allows you to generate your account, your testnet account. I think the only requirement here is NPM. Okay, so you need to have Node installed, basically. Node and Git, I think those are the only two prerequisites here. So I'm kind of assuming folks here, if you're developers, you have these tools installed. But again, if you're stuck, let me know. I already have it installed, but I'll go ahead and run this anyway. It won't hurt anything. Yeah, and if you did open that first link, you'll see this page instead. It's basically the same instructions. I think we're stuck on slow internet again. and then installing the shade agent CLI as well. I'm just doing these two things in parallel. Okay, that worked. Good. All right, the next thing is the testnet account. I think this command is actually a little bit wrong. I'm sorry for that, but I'll show you the correct command here. I think the tooling has just kind of evolved a little bit. Yeah, okay, the near CLI is installed now. So I can just run, like this, for example. Right, and you can see here the create account. Let me scroll up. Right, so this is what we're going to run, near create account, this command. And we're going to pass in the mnemonic that we created. We need that mnemonic because the shade agent needs access to it. Okay, so this is the correct command, near space create dash account space dash dash use faucet. The use faucet will give you some testnet near. Dash dash network ID testnet, I'm actually not sure if that's required. And then we pass in the seed phrase here that we created. And again, that seed phrase should be this one here. I'll actually, it doesn't matter. This is a new seed phrase, so we'll get I'm going to use this one from yesterday. I'm going to just give it a different name. See if this works. Okay, cool. So now we have account credentials. And if we actually look at the contents of this file, you'll see it's just a public key and a private key, basically. The mnemonic is not there, but we have the mnemonic. Okay. Sorry, there is one more prerequisite, which is Docker. As I said in the presentation, when we run things inside a TE, inside a trusted execution environment, we need a code hash, right? We need a way to prove that the code that's running is what we expect. And the way we do that is with a Docker container, right? The Docker container has a particular code hash associated with it, so we'll get a proof that the Docker container is executing faithfully inside the TE. So yes, sorry, the prerequisites are Git, NPM, and Docker. And obviously I already have Docker installed here. All right, next step is the configuration file. Let's take a look at that. So I've just made a copy of the example file and called it .env.development.local. All right, so what's inside here? It wants a near account ID, it wants a seed phrase that we set up a moment ago, contract ID. Here's the code hash. So the code hash is the Docker container, basically. So this part up here is when we run locally. And then, I don't know if we'll have time, but we'll try as well to run on Fala in the cloud. And so the code hash is different when we run on Fala. So I'm just going to insert the near account ID and the seed phrase. I also mentioned in the presentation that near accounts are all named accounts by default. So testnet accounts end in .testnet. So lane shade agent 3.testnet, that's a testnet account. Mainnet accounts end in .near. So again, my mainnet account is lane.near. And then let me put the seed phrase here as well. Okay, and then again, that's how the shade agent has access to create transactions on our behalf if we give it the seed phrase. Okay, and then we need to fill this in as well. I think that's all we need to run locally. Let's see if it works. Okay, so I'm going to try running the shade agent tooling now. Actually, sorry, I think I need to run npm install first. Okay, good. Now I'm going to run the shade agent, CLI, see if this works. It's creating an account, that's good. Created the account. So again, the presentation, I talked about how you have these agent workers that are communicating with an on-chain contract. So this is what it just did. It just created the on-chain contract that validates the workers. And then I want to run this in parallel to that. This is the front end. Let's see if I can get this to work. All right, fingers crossed. I think it's running. Let's try to talk to it. All right, not yet. Let's see. I think it's this is the issue, HTTPS. Okay, good. The app is running. Awesome. Right. So how do we interact with it? We do it using the web. Okay, so let's first try to see the account information. Sorry, I think this is the browser. It's going to keep adding the S. It's annoying. Failed to get agent account. Let's see what's going on. Yeah, I'm not sure what that error means. But so, we talked about how these shade agents are multi-chain by default. So it's actually derived an Ethereum account for us here, right? And what this, I guess I failed to explain, what this agent actually does is it acts as an oracle for the Ethereum price. So what's actually going to happen here, assuming this works, is we're going to download the Ethereum price from an off-chain API. We're going to get it from, I don't know, Coinbase or something like that. And then it's going to go, using my near account credentials, it's going to create an Ethereum transaction and update the price of ETH. I know we're almost out of time, so let me kind of go ahead and just see if I can get that part to work. One missing thing here is this Ethereum account needs to be funded, so I'm going to send a little bit of Sepolia testnet Ether to it. And if anyone else here is following along and wants to do this as well, if you can give me this Ethereum account, then I can send you some testnet ETH as well, so you can try this also. So I'm just sending a little bit of Sepolia testnet ETH to this address. Okay, that's confirmed. And then the final step is just to try to create the transaction. So let's see if this works. I have 1 minute left. This is the new Perplexity browser called Comet, by the way. I don't know if anyone's used it. It's very dumb that every time I open a page, it verifies if I'm human, so I'm really not enjoying this browser. Okay, it failed to send the transaction. That's all right, we tried at least. What's the error here? Let's see. I'm just going to try restarting it. Okay, I think it failed earlier because it didn't get this far. So there was some missing piece of the puzzle here, maybe because I didn't fund the Ethereum account. So, okay, now it says the shade agent is ready. Let's try one more time. Okay, so here, got the ETH price. Wow, ETH went up a little bit, $4,400. All right, and it created, so this is what you saw earlier, it requested the signature from the on-chain contract. It called the method call. This is the Ethereum transaction that was created. I think it's still waiting for that to be mined, maybe. Let's see. Okay, got a signature from the MPC network. That's good. Okay, it worked. So now we can actually see this on the testnet, on the Sepolia. Okay, I know I went through that very quickly, but thank you guys for following along. Really excited to share, this technology we're building with you guys. Again, I'm happy to follow up, if this stuff is exciting to you guys. Let me just find my slide with my contact information again and put this up so you guys can get in touch. All right, thank you very, very much. Thanks for hosting me. I think we can say that demo worked, almost.